Introduction in the contemporary theater of war, particularly on the Ukrainian front. A paradigm shift is underway as robotic forces move from the realm of science fiction to practical, on-the-ground applications. Once relegated to auxiliary roles as unmanned aerial vehicles, UAVs, unmanned ground vehicles, UGVs, and automated weapon systems, robotics have now evolved into fully integrated tactical units. These so-called robot units, or robot brigades, are not only complementing human soldiers but in many instances are poised to assume critical roles in combat scenarios. This essay examines how these systems are transforming military doctrines, the nature of combat, and the broader strategic implications for global security. The evolution of robotic warfare. Historically, unmanned systems were deployed as a means to augment human capabilities by providing reconnaissance support, delivering limited firepower, and reducing risks to personnel. However, technological advancements in artificial intelligence, AI, sensor integration, and network connectivity have paved the way for more sophisticated robotic platforms. In Ukraine, for example, we observe an evolution from isolated unmanned systems to fully coordinated robotic units that operate as independent tactical formations. These units consist of multiple robotic platforms, ranging from ground-based vehicles to aerial drones, integrated through centralized command and control networks. The result is a cohesive fighting force that can perform diverse missions including reconnaissance, mine clearance, target acquisition, and direct engagement with enemy forces. The transformation is underpinned by improvements in autonomous navigation, sensor fusion, and real-time data processing. Ground robots are now equipped with advanced lidar, infrared, and thermal imaging sensors that enable them to operate in low-visibility environments such as urban combat zones or densely forested areas. In parallel, drone swarms are being developed with the capability to execute coordinated attacks, sharing information instantaneously through low-latency communication networks. This level of integration marks a significant departure from previous iterations of unmanned systems that operated largely in isolation and with minimal interconnectivity. Technological integration and operational capabilities. Modern robotic units leverage a combination of hardware and software to achieve high levels of operational efficiency. Central to this is the integration of AI-driven decision-making algorithms that allow robots to interpret complex battlefield data and act autonomously when necessary. For instance, during reconnaissance missions, ground robots can independently navigate through unknown terrains while avoiding obstacles and potential threats, thanks to real-time processing of sensor data. Similarly, drone swarms use machine learning techniques to optimize flight paths, adjust formations, and execute rapid, coordinated strikes on high-value targets. Moreover, these systems are designed to operate in harsh electronic warfare environments. The Ukrainian battlefield, with its challenges such as GPS jamming and communication interference, has forced developers to incorporate robust countermeasures. Techniques such as decentralized network architectures, redundant communication channels, and adaptive signal processing ensure that robotic units maintain functionality even under adverse conditions. In essence, the ongoing field tests in Ukraine are not only refining the mechanical and electronic components of these systems but are also driving advancements in AI algorithms and cybersecurity measures. One of the most striking aspects of robotic warfare is the speed and precision with which these systems can operate. In conventional warfare, decisions are often slowed by the need for human deliberation and command hierarchies. In contrast, autonomous robots can make split-second decisions based on a continuous stream of sensor data. This rapid response capability is particularly advantageous in environments where time is of the essence, such as in urban combat or when facing highly mobile enemy units. The ability to act decisively without human intervention may well define the future of tactical engagements. Ethical and legal considerations. While the technological progress in robotic warfare offers significant tactical advantages, it also raises profound ethical and legal questions. One of the primary concerns is the level of autonomy granted to these systems. When robotic units are given the authority to engage targets without direct human oversight, the risk of erroneous decisions increases. Issues such as algorithmic bias or sensor malfunction could lead to unintended civilian casualties or even friendly fire incidents. Such incidents would not only have immediate humanitarian consequences but would also undermine the legitimacy of autonomous systems in military applications. International law and military ethics are currently struggling to keep pace with these rapid advancements. Debates center on whether robotic systems should be allowed to make life and death decisions and how accountability should be determined in cases of error. The lack of clear regulatory frameworks means that in the event of a malfunction, it remains ambiguous whether responsibility lies with the manufacturer, the military operator, or the algorithm itself. This legal gray area is compounded by the possibility that adversaries might also deploy similar systems, thereby triggering an arms race in autonomous weapons technology. There is also a broader societal debate on the potential consequences of relying heavily on robotic systems in warfare. While reducing the risk to human soldiers is a compelling argument, critics caution that the diminished immediate cost in human lives might lower the threshold for initiating military conflicts. In other words, if decision-makers know that they can wage war with minimal casualties on their own side, there is a risk that the political barriers to engaging in conflict could be eroded. Therefore, establishing robust international norms and regulations is essential to ensure that the deployment of autonomous weapons does not lead to unintended escalations or abuses. Operational examples from the Ukrainian front. The Ukrainian conflict has provided a real-world testing ground for various robotic systems, highlighting both their potential and limitations. Early in the conflict, drones such as the Bayraktar TB2 garnered significant attention for their effectiveness in targeting enemy armored vehicles and supply lines. However, as the conflict evolved into a more protracted stalemate, there was a clear need to enhance the survivability and versatility of these systems. This led to the emergence of dedicated robotic units that are not only capable of surveillance and strike missions but can also perform tasks traditionally assigned to human infantry. For example, robotic units have been employed to conduct reconnaissance in hazardous environments such as minefields or areas suspected of harboring enemy combatants. Equipped with thermal imaging and acoustic sensors, these robots can identify potential threats and relay critical information back to command centers. In addition, some robotic platforms have been modified to carry modular weapon systems, enabling them to provide direct fire support during engagements. This multifunctional approach, combining reconnaissance, communication, and firepower, illustrates the strategic flexibility that robotic units can offer on the modern battlefield. The integration of robotic units in Ukraine has also led to significant improvements in command and control. By establishing centralized networks that coordinate both manned and unmanned systems, military forces have been able to synchronize operations more effectively. This network-centric approach allows for real-time adjustments to tactics based on the rapidly changing conditions of the battlefield. For instance, if a particular area becomes compromised by enemy electronic warfare measures, the command center can quickly reroute robotic units to alternative positions while simultaneously deploying countermeasures. This dynamic reconfiguration of forces underscores the importance of robust communication and adaptive planning in modern combat scenarios. Cybersecurity and electronic warfare. As warfare becomes increasingly reliant on digital networks and autonomous systems, cybersecurity emerges as a critical vulnerability. Robotic units, by virtue of their dependence on software and communication links, are susceptible to hacking and electronic interference. In conflict zones like Ukraine, where adversaries are known to engage in sophisticated cyber operations, ensuring the security of robotic platforms is paramount. Cyber attacks on military systems could lead not only to operational failures but also to the possibility of hostile takeovers, where enemy forces might repurpose captured technology against its original operators. To counter these threats, significant research is being directed towards developing secure communication protocols and resilient software architectures. Techniques such as end-to-end encryption, distributed computing, and real-time threat monitoring are being integrated into robotic systems to safeguard against potential breaches. Additionally, military strategists are exploring the concept of cyber hardening, to ensure that robotic units remain operational even if certain network nodes are compromised. The challenge lies in striking a balance between connectivity, which is essential for coordinated operations, and security, which is crucial for maintaining control over autonomous systems. The integration of AI in these systems further complicates the cybersecurity landscape. Machine learning algorithms, while capable of enhancing decision-making and operational efficiency, can also be exploited if adversaries manage to introduce subtle manipulations or adversarial examples into the data stream. In response, researchers are developing robust AI models that are resistant to such attacks, employing techniques like anomaly detection and continuous learning to ensure that the systems remain secure even under duress. Strategic implications and global impact. The deployment of robotic units on the Ukrainian front has significant strategic implications that extend far beyond the immediate theater of operations. As major military powers witness the effectiveness of these systems, there is an increasing impetus to invest heavily in research and development of similar technologies. The future battlefield is expected to be characterized by a hybrid force where human soldiers and robotic units operate in a tightly integrated manner. Such forces could potentially transform conventional military doctrines, shifting the emphasis from sheer manpower to technological superiority and network-centric warfare. For instance, the United States has already begun to integrate robotic systems within its concept of multi-domain operations, emphasizing the need for rapid information sharing and autonomous decision-making. Meanwhile, nations such as Russia, China, and Israel are not far behind, each allocating substantial resources to develop their own robotic platforms. This global race for robotic and AI superiority is likely to redefine the balance of power in future conflicts. Countries that successfully harness these technologies may gain a decisive edge, rendering traditional metrics of military strength, such as troop numbers and firepower, less relevant. Furthermore, the proliferation of advanced robotics has economic and industrial ramifications. The defense sector is witnessing a surge in innovation, with both established defense contractors and emerging tech startups vying to capture a share of this rapidly expanding market. Investments in robotics and AI are driving the development of new manufacturing techniques, supply chain optimizations, and even dual-use technologies that could benefit both military and civilian sectors. The commercialization of these technologies is likely to accelerate as production costs decrease with scale, making advanced robotic systems more accessible to a wider range of actors. The strategic shift towards robotic warfare also necessitates a rethinking of international alliances and defense strategies. Traditional alliances, which have been predicated on shared values and mutual defense commitments, may need to be recalibrated in light of new technological capabilities. Nations that excel in robotic warfare could emerge as new centers of power, prompting realignments in global geopolitics. Moreover, the integration of autonomous systems into national defense strategies may lead to a form of techno-diplomacy, where the sharing of technological expertise becomes a key aspect of international relations. Challenges in integration and doctrine development. Despite the numerous advantages offered by robotic systems, integrating them into existing military doctrines is not without challenges. One of the primary issues is the interoperability between manned and unmanned systems. Human soldiers and robotic units have inherently different operational characteristics, and synchronizing their actions requires a fundamental rethinking of command structures and tactical protocols. The transition from a human-centric model of warfare to a hybrid model that fully leverages robotic capabilities necessitates extensive training, new communication protocols, and a cultural shift within military organizations. Additionally, the rapid pace of technological change poses significant challenges for military procurement and doctrine development. Traditional defense acquisition cycles, which can span several years, are ill-suited to the dynamic and rapidly evolving field of robotics and AI. This creates a tension between the need for cutting-edge capabilities and the bureaucratic processes that govern military modernization. In order to remain competitive, military organizations must adopt agile procurement strategies and foster closer collaboration with the tech industry. This could involve creating dedicated research and development units, establishing public-private partnerships, and even rethinking the role of traditional defense contractors in the modern era. There is also the issue of training and adaptation for military personnel. As robotic systems take on increasingly complex roles, the responsibilities of human soldiers are evolving. Rather than being the primary agents on the battlefield, human operators may find themselves in supervisory or decision-making roles, tasked with managing and coordinating autonomous systems. This shift will require new forms of training that focus not only on traditional combat skills but also on technological literacy. Cyber defense and systems management. The development of effective human-machine interfaces, including augmented reality, AR, and brain-computer interfaces, BCIs, will be critical in ensuring that human operators can effectively oversee robotic operations without being overwhelmed by data or losing situational awareness. The future of hybrid forces. Looking ahead, the trend toward robotic integration on the battlefield is likely to accelerate, resulting in a new era of hybrid forces that combine the best attributes of human soldiers and autonomous systems. In these future armies, human ingenuity and ethical judgment will complement the speed, precision, and endurance of robotic units. This synthesis of capabilities could lead to a transformative change in military operations, where decisions are informed by real-time data analytics and executed with machine-like efficiency. One of the most promising aspects of this hybrid model is the potential for enhanced situational awareness. With a network of interconnected sensors, drones, and ground robots, military forces can achieve a level of battlefield visibility that was previously unimaginable. Real-time data from multiple sources can be aggregated and analyzed using sophisticated AI algorithms, providing commanders with a comprehensive understanding of the operational environment. This sensor fusion capability enables rapid identification of enemy movements, early warning of potential ambushes, and dynamic adjustments to tactical plans. As a result, hybrid forces are better equipped to respond to emerging threats and capitalize on fleeting opportunities. Moreover, the integration of robotic systems offers significant benefits in terms of risk mitigation. By deploying robots in high-risk environments, such as minefields, urban combat zones, or areas contaminated by chemical or biological agents, military forces can reduce the exposure of human soldiers to life-threatening hazards. This not only preserves valuable human capital but also enhances the overall operational effectiveness of the force. In scenarios where collateral damage or civilian casualties are a concern, robotic systems equipped with precision-guided munitions and advanced target discrimination algorithms may offer a more controlled and measured response than traditional artillery or infantry assaults. The emergence of hybrid forces also prompts a re-evaluation of military leadership and command structures. Future military operations may require leaders who are not only adept at conventional warfare but also possess a deep understanding of technology and data analytics. Commanders will need to be proficient in interpreting real-time information, managing networks of autonomous systems, and making decisions based on complex, multi-layered inputs. This shift in skill sets will likely drive changes in military education and professional development, with a greater emphasis on interdisciplinary training that bridges the gap between traditional combat tactics and modern technological competencies. Implications for international security and arms control. The widespread adoption of robotic systems in military operations has far-reaching implications for international security and arms control regimes. As robotic and AI technologies become more accessible, there is a risk that these systems could proliferate beyond the control of nation-states. Non-state actors, insurgent groups, and even terrorist organizations may seek to acquire or develop autonomous weapons systems, thereby complicating the already challenging landscape of modern conflict. The diffusion of these technologies raises critical questions about how to prevent their misuse and how to establish effective controls over their proliferation. International efforts to regulate autonomous weapons have thus far been hampered by divergent national interests and the rapid pace of technological development. While some nations advocate for stringent controls on the deployment of lethal autonomous systems, Others argue that such restrictions could hinder technological progress and compromise national security. In the absence of comprehensive international agreements, there is a growing risk that a new arms race could emerge, one that is defined not by traditional munitions and troop deployments but by the sophistication and autonomy of robotic systems. Furthermore, the use of autonomous weapons in conflict zones like Ukraine may prompt a re-examination of existing arms-controlled treaties and international legal frameworks. The deployment of robotic units challenges traditional notions of accountability and proportionality in warfare. As autonomous systems become more integrated into military operations, determining liability in cases of malfunction, misidentification, or unintended escalation will become increasingly complex. This underscores the urgent need for international dialogue and collaboration to develop robust legal and ethical frameworks that address the unique challenges posed by robotic warfare. Economic and industrial dimensions. The rapid evolution of military robotics is not only a strategic imperative but also an economic opportunity. The defense industry is witnessing a surge in investment in AI and robotics, with governments and private enterprises alike channeling significant resources into research and development. As production scales up and technologies mature, the cost of deploying advanced robotic systems is expected to decline, making them accessible to a wider range of military actors. This democratization of advanced technology could have transformative effects on global security dynamics, as smaller nations and non-state actors might gain access to capabilities that were once the exclusive domain of major powers. The economic impact extends beyond the battlefield. Advances in robotics and AI are driving innovation across multiple sectors, including manufacturing, logistics, healthcare, and transportation. The dual-use nature of these technologies means that breakthroughs made in military research often find applications in the civilian realm. For example, autonomous navigation systems developed for ground robots can be adapted for self-driving vehicles, while sophisticated sensor networks may enhance urban infrastructure and emergency response systems. As such, the investment in military robotics has the potential to generate significant economic spillover effects, fostering innovation and growth in various industries. However, the rapid commercialization and proliferation of robotic technologies also bring challenges. As more actors enter the market, concerns about quality control, cybersecurity, and ethical usage become increasingly prominent. Ensuring that these technologies are deployed responsibly, both in military and civilian contexts, will require coordinated efforts from governments, industry leaders, and international regulatory bodies. Establishing standards for interoperability, safety, and accountability is essential to harness the benefits of robotic innovation while mitigating potential risks. Conclusion: the integration of robotic forces into the modern battlefield, as exemplified by their deployment in Ukraine, marks a pivotal moment in the evolution of warfare. The transition from isolated unmanned systems to fully integrated robotic units is redefining military doctrines, challenging traditional notions of combat, and prompting a re-examination of ethical and legal frameworks. As robotic systems become more sophisticated and autonomous, they offer the promise of enhanced operational efficiency, reduced casualties, and unprecedented situational awareness. At the same time, the rapid pace of technological change and the inherent risks associated with autonomous decision-making underscore the need for rigorous cybersecurity measures and robust international regulations. The Ukrainian conflict serves as both a testing ground and a catalyst for the development of advanced military robotics. Lessons learned on the battlefield are driving rapid innovation in sensor integration, AI algorithms, and secure communications. As major powers invest in these technologies, the global security landscape is poised for a fundamental transformation. One where hybrid forces, composed of both human soldiers and robotic units, redefine the nature of military power. In this new era, strategic superiority will be measured not only by the size of one's armed forces but by the ability to deploy and manage cutting-edge autonomous systems with precision and ethical responsibility. Looking ahead, the widespread adoption of robotic warfare is likely to reshape international alliances, spark new arms races, and compel policymakers to confront challenging ethical dilemmas. While the potential benefits of robotic systems are substantial, from reducing human casualties to enhancing operational efficiency, the risks of miscalculation, cyber vulnerabilities, and unintended escalation remain significant. As nations navigate this uncharted territory, there is a pressing need for collaborative efforts to develop comprehensive legal frameworks and international norms that can guide the responsible use of autonomous weapons. In summary, the emergence of robotic units in modern conflict represents a seismic shift in military strategy and technology. The experiences gleaned from the Ukrainian front offer valuable insights into both the capabilities and limitations of these systems. As we stand on the threshold of a new era in warfare, the integration of robotics and AI demands a balanced approach, one that embraces technological innovation while rigorously addressing the ethical, legal, and strategic challenges that accompany it. Only through such a measured and cooperative approach can the global community hope to harness the transformative potential of robotic warfare while safeguarding the fundamental values of human dignity and international stability.